So welcome everyone. Welcome to our webinar about Applanix PPK today. Thank you very much for joining this webinar. Seems like there's a big audience today and we really appreciate that. My name is Nico Jaeger. I'm the product manager of our POSPac software variants, which comprises desktop software as well as cloud software, such as our Applanix PPK web app being demonstrated today. With me is Hani today, our development manager for our cloud solutions, who will be helping me on the Q&A session. We also have our marketing team here today in case of there's any technical issues with this webinar. The session is split up into three sub-sessions: a presentation with PowerPoint slides, a quick demo on the Applanix PPK web app itself, followed by the Q&A session. Okay, a little bit about the logistics here for this webinar. The presentation itself will likely last about 20 minutes, followed by the web app demo, which I suspect will take 10 minutes. And then we have time for the Q&A session, probably about 15 minutes. The webinar will be recorded and shared with you later on. All attendees are muted. If you have any questions during the webinar, please use the question box. We will try to answer during the Q&A session as many questions as possible. If there are some that we cannot answer due to the load of the questions, we'll follow up in an email separately to you. Okay, so let's start and throw the question, what is Applanix PPK? Applanix PPK is an easy-to-use web app cloud service to post-process kinematic GNSS differential position from UAV or drone data. The processing itself is happening in the cloud, so you can consider that product or module as a PPK as a service. It's basically optimized for camera UAV payloads, and it combines POSPac techniques. POSPac typically able to generate solutions from GNSS INS systems, combines those techniques with the Trimble GNSS technology. Applanix PPK is still in beta mode, and the commercial part hasn't been launched. We intend to offer a subscription model on monthly and annual plans. As we deduct the number of flight minutes being processed, we consider this also a pay-per-use model, especially for the add-on plans, which I will explain a little later. So how does PPK work? PPK stands for post-process kinematic, and it is an alternative approach to RTK. RTK is probably very known to you. You're getting real-time corrections for the rover system to get accurate trajectory solution. In PPK, we rather merge the rover GNSS data with base GNSS data later on, or we use other GNSS correction data to geotag the images. This is handled in forward and backward processing. So you integrate your solution in time forward and backward. And because you do that, you're able to see the remaining errors, GNSS errors. So at the end, you're getting a smooth trajectory, which mitigates the GNSS errors. What are the benefits then of PPK versus RTK? PPK does not require a real-time link via a receiver or transmitter, like a radio link or internet. It's always something that you do later. So that also means you're not exposed to any potential GNSS correction interruptions, like you could have because of using internet or because of a radio link that's not working. There's also no additional hardware required in the field. And of course, as I said before, you have a very smooth solution because you process forward and backward in time. And at the end, that will give you a higher precision of your solution and a more robust solution. We also support a processing mode called PPRTX, which I will explain a little later on. And that service provides you correction data within minutes after data acquisition. So we wanted to make this very simple for you. It's as easy as drag and dropping your raw files into this app, submitting your project, and you're going to receive an email with a download link. And that's far different from any desktop software, obviously, where you have a lot of knobs and buttons to, to improve your solution or to monitor your solution whatsoever. So what are the input files that we need for ApplanixPPK? Mandatory is always the Rhinix rover file from your drone. The Rhinix rover file shall have at a minimum GPS L1 and L2 observations. Ideally also GLONASS observations or any other additional observations from satellite navigation systems such as Baidu or Galileo. The minimum is GPS, as I said. What is optional? You can provide us a Rhinix base file in the ApplanixPPK app in order to merge the base and the rover data. A photo ID file. A photo ID file contains the exposure times of the images and the image numbers. So at the end, you're going to get a solution, position solution at the exact exposure times. Or if you don't have the photo ID file, you can present the event file. An event file also contains the exposure timestamps, but no photo number at that time. And in addition to the event file, you would need to have an image folder that contains all of the images. And we have this photo ID editor embedded in this ApplanixPPK web app, which allows you to create a photo ID file. So if you don't have that photo ID file, as I'm saying, you can use the photo ID editor. How does the photo ID file look like? Typically, we would need to have the time information. Again, this is a timestamp of the image exposure time in GPS seconds, co-aligning with the photo number. And in the web app itself, we have a button called Create Photo ID. And from there, the web app will guide you through the input files that we need, and it will generate that file automatically for you. So what if you don't have a base station available? We do have two other modes of processing, two other services. One is called PPRTX. That gives you a correction data within minutes after data acquisition. And the other concept is called Smart Base. I will explain this now on the next slides. So what is PPRTX? PPRTX stands for Post-Processed RTX. So what we are using here is the Trimble RTX network. Trimble has a network of tracking stations worldwide, collecting data day and night. All data are processed in a control center, and via a smart algorithm, it creates a set of correction data for the rover. It corrects for the standard GNSS error budget, such as satellite orbit errors, clock errors of the satellites, or atmospheric errors. This service is covered worldwide, and as I said, the corrections are available minutes after mission completion. However, we have to distinguish here between two different regions. We have a so-called fast region, and the fast region uses a denser network of stations to deduce a regional correction model, while the standard region relies on a global model. In both cases, if you process the data, you can obtain an accuracy of 3 centimeter horizontal error and 6 centimeter vertical. The fast regions right now are over Central Europe, as you can see on the right side here, and North America. The big advantage here for the fast regions is that the convergence time for the solution is very quick. It's about 1 or 2 minutes. And that allows you to process data of a time span of 10 minutes. For the standard region, which really covers the rest of the world, the convergence time is a little slower, and you would need to have a longer rover data time span. So the minimum is approximately 30 minutes to obtain the RMS that I just mentioned. The other concept is called smart base. Smart base is using free available stations worldwide. It's also known as a core stations. So in that case, the web app would use stations surrounding your mission area. And within this network of the stations, it is smart enough to estimate the atmospheric errors, clock errors, and orbit errors to correct the errors right at the rover at each epoch. So we are kind of applying a virtual reference station concept. So it's like a base station is following your UAV, your rover, and because it's very close, all of those errors are canceling out automatically. So this smart base concept also supports a network adjustment. What does that mean? The base stations are having typically coordinates. We have to make sure that within the network of base stations, the coordinates are homogeneous and they match to each other. So there's no tension in that network. So in the background, there's an adjustment process running that ensures all of those coordinates that we might get from different services, they're matching together and they're creating a very homogeneous network of stations. Now you can imagine that because we're using free stations that are being available, that that we are not getting stations, in the same density all over the world. So you have regions where you have a very dense network, and you have regions where you have only a sparse network. In order to check that in advance, we have another web app. It's called Smart Base Planning Tool. That's all free of charge in that case, where you can check in advance what the coverage is of the base stations. Once you know it, you can apply it in the ApplanixPPK app. So what happens if you don't have coordinates for your base station, right? So let's assume you have a base station which was pitched in the field. You didn't pitch it over a known point, or you didn't triangulate the point in another piece of software or another piece of service. We are using the Trimble RTX service again. That allows us to survey in the coordinates of such a base station. The requirements are that you need to have phase measurements for L1 and L2 for at least 60 minutes, and again from at least GPS. You can have it supports all the satellite navigation systems like Galileo, GLONASS, Baidu, etc. But the minimum would be to get it from GPS. The format that we support here is RENX file format and Trimble format, and you need to have a calibrated antenna model on your base station. And there's a link here that does list all of the supported antennas. But if that's the case, again, you don't need to hassle about getting coordinates from somewhere. It's just all embedded in that web app, and it will do the job for you. What are the deliveries of ApplanixPPK? The first file that we deliver is a standard ASCII file in the UTM coordinate system or mapping frame, and it provides a solution at the exposure time, given the fact that you have also the photo ID file. Another output file is a UAS master project file, also in the UTM system at the exposure times. UAS master is a photogrammetric software tailored for UAV application from Trimble Geospatial. And there's a direct handshake between the ApplanixPPK web app and this piece of software for photogrammetric jobs. In addition, we provide the Applanix binary ASPET file at the frequency of 1 Hertz. That's a very known format in the industry nowadays, and an Applanix ASCII file, again in UTM and geographic coordinates. So UTM would give you Cartesian coordinates, will also give you geographic coordinates, latitude, longitude, at the frequency of 1 Hertz. And very important, you're going to get a report file and log files. And the report file contains a lot of graphs, for instance, to give you feedback about the achieved performance, so the accuracy. And the log files give you also an insight of, how the process worked, what were the input files, etc., etc. So this is all bundled into a zip file that is provided to you in an email, or you can also download the zip file directly from the web. So in terms of commercializing this product, as I said, right now it's all in beta mode, so everyone can use it as much as you want. But going forward, at some point, it's going to be commercialized. And I don't want to address it too much here, but what we have in mind is basically a subscription model, and we call it a so-called base plan. And there's two options here, either a monthly plan or an annual plan. Well, the monthly base plan will allow you to process 50 minutes of flight data on a monthly basis, whereas the annual plan would allow you to process 600 minutes over 1 year. And if I say 50 minutes or 600 minutes, it means flight minutes. So we're ignoring any static data. Any data on the ground are going to be ignored. It's reading flight data that are conserved here. So should this amount of minutes be not sufficient for you to, for that given period, you can always purchase add-on minutes. We have two add-on plans right now. One is a 100-minute scenario, and the other one is a 500 minutes. What does it mean? If you purchase 100 minutes, you can consume them over a period of 30 days. And the same applies for the 500-minute concept. So you can buy as many add-ons as you want in order to process your amount of data. So let's go to the features and kind of repeat this. So we're supporting 3 different processing modes: single base, smart base, PPRTX. In terms of using single base, you would need to provide us a base station file, whereas for the other 2 options, the web app will take care of it. We have the survey in function that allows us to process the base coordinates. So that means you can pitch the base station wherever you want in the field. Coordinates automatically processed and then used in the web app. We have a photo ID editor online tool, so you don't need to do any manual editing at home to get this photo ID file done. The web app will take care about it. So for instance, we're directly supporting the RMRK file from the DJI Phantom 4 RTK system, but any other ASCII event file will help. So as long as you provide us an ASCII file that has the event time, so the time when the image was triggered, and a number, and the images, we're able to get this going for you. We export in multiple files and formats, so ASCII standard file, US master project file. Again, there's a direct handshake between our web app and the ZOAS master photogrammetric software product. And in addition, we give you a 1 Hertz trajectory output in ASCII and ASPET form. Should you need to reprocess any data because you made a mistake, let's say you did upload the wrong base file or something like that, you can always reprocess, and we're not going to trigger additional cost or deduct the minutes. That is possible. But you would need to use our project history page, which is this page here on this one, to do that. The detailed report is available with various plots, allows you to evaluate your data, and we keep a record of all of your data. So you can go back, reprocess, or re-download your solution, as long as you have a valid account. So what are our benefits here? So you will always use the latest software version. In this case, the vendor has the responsibility to update the software in the cloud. It's not like for desktop software where users need to do it and maybe even purchase maintenance. So you always run the latest and the greatest. You also will need to purchase any software. So you kind of reduce your capital investment for it. You also reduce the number of ground control points, because if you have a very good PPK solution, you have a very stable geometry. And that will make the entire mission more efficient. So you probably, in some circumstances, you only need one ground control point, or even no ground control point, really depending on what accuracy you are aiming for. The results are available in a few clicks. You will see that. And there is not much of learning here. So as opposed to have desktop software, you have always a learning period for desktop software, but here it's really straightforward. A few clicks, you're done. You never lose a mission. We keep the missions in the system, and also because you run PPK processing and you're not relying on RTK and the RTK link, you never lose a mission basically. You can always process as long as your raw rover data are available. You don't need a base station. Please remember, we have the PPRTX and the smart base concept, providing you good solutions. We're running a subscription model, so you don't need to purchase something. It's on the monthly or on the annual period, and we follow the pay-per-use model, so you only pay for what you consume. Okay, so that brings me to the demonstration of the web app itself. I will quickly jump over to this one, but also stop sharing my screen for that time. So give me a couple of seconds to switch over to the web app. So marketing team, is my screen visible or is it very tiny right now?
Looks good.
Okay, then I go from here. So I'm right now on the web app. So I'll have to assign a project name. So let's call that webinar. And as I said before, the minimum that we need to have is a Rhinex rover data. So I can drag and drop, or I choose it from a list here. And then I can select my processing mode. As we saw from this presentation, we have the PPRTX, smart base or single base. For now, I just go with the PPRTX mode. And at the bottom here, you just enter your email address and you can submit the project. That's all you need if you want to have a trajectory processed. In the meantime, I'm showing you here under my projects the history of the project, so you can see all the projects that you processed. The green ones are the ones that were successful, red ones are the ones that failed. So for the project that I just fired to the cloud, this is in processing mode. So while this is processing, let's go back here, create another project because I wanted to show you more advanced functionality here. I take the same Applanix file, take the same processing mode here. There's a section here for the photo ID file. So if you have a photo ID file, you can simply click on it and load it, or you go through the create photo ID file function. I'll demonstrate that now. So you need to choose an event file, such as an MRK file from the DJI drone. Click next. And there's a little tool here that allows you to align the columns. So we need to know what column has the events in it and what column has the event time in it. So that means you can have, any other ASCII file. As long as you have these two columns, we're good. You can just align it with the according columns. For the MRK file, it will automatically detect it. So there's nothing that you would need to do. Just click next. And I would choose the images that belong to my mission. Same here, drag and drop, or you go to the Explorer, select all the images, say open. It's loading, it has loaded 204 images, so I click next. And it will now tell me I have an active number of events, which is 204, and I have active images 204. So those numbers need to align in order to create the photo ID file. If you have any crap events because you triggered at the ground and the image is not relevant and the image is even not stored somewhere, you can always deactivate an event from here, right? But important is that those two numbers match, and then we can click on generate the photo ID. That's all you need to do from here, and then you can click submit a project. However, before we do that, I want to show you the other processing modes. For instance, the single base mode. So if you have your own base station, you can load the base station here. And then the question is, where are the coordinates coming from for the base station? So either you use the RTX survey in function that I just explained, or you click on from Applanix base position. In that case, the coordinates are coming from the Applanix file header. So if you trust them, they're okay, you can use them. Or you manually enter the base coordinates. That can be done in geographic coordinates, degrees, minutes, seconds, or in decimal degrees. And the same for the antenna. If you have a specific antenna height information, you can do that from here as well. Okay, I go back to the PPRTX mode. I have my photo ID file now, and I can submit the project. So here it's success. So the project has been uploaded. There's always an ID connected to it. So let me go back here to the project list. So my history page. I have now two or both projects sitting in the queue for in processing mode. Once it is finished, and I hope that will still happen in a few seconds, you can click on download here. Let me continue and take a previous project. And that has been downloaded, so let me go there. So this is the zip file that's downloaded, extracted. And I wanted to show you what's inside there. So first of all, you have a report. It's a PDF file that contains a lot of information, metadata, as well as graphs. For instance, here you can go to the smooth performance metrics. That shows you the estimation of your position over time in 3D. Let me make this a little smaller. that way. So we have the north position, the east position, the down position over the GPS time, which is in GPS seconds. So we are seeing the 3 centimeters approximately horizontally and the 6 centimeter below 6 centimeter vertical arrow. You can also check the number of satellites that were used, for instance, here. Other statistics, backward forward solution. So how well does the forward and reverse solution match to each other, etc. So there's a lot of information in here that basically contribute to solution evaluation. The other file, for instance, this one here, photo ID EO mission 1. We open this one. That contains your final solution. There's some header information here, and then you have your photo number. You do have the time information, easting, northing, height, easting, northing, height information, and you have that information also in latitude and longitude information, so geographic coordinates. So that piece of file contains your final solution. You would take this one into the photogrammetric software, whatever software you use, to provide the exterior orientation in terms of position for the exposure times of the images. So there's a bunch of other files in there. Well, I'm not going through that. If you have those questions, we can take that later on. So let me go back here. Refresh. You see that now I pressed refresh. The other data set is finished, the first one that we fired, and the other one is still in processing mode. Again, the same time, you would get an email now with the link, the same link that's displayed here. You'll get that in the email. You can click on it and then get the data also from there. Okay, let me go back quickly to the presentation. So I will stop sharing my screen for a second. I'll be back for you. Okay, I'm back here. That was the presentation of the web app itself. And next session is all about the questions and answers. So I hope you fired some questions into the chat room. I'll hand over now the word to Henny, who will address those questions, and then we can discuss together the answers.
Okay, thanks, Nico. So we do have about 7 or 8 questions, so we'll just go through them one by one. So the first question from Michael: what versions of Rhinix are supported?
Yeah, Henny, do you know? Or
I don't remember off the top of my head specific version, to be honest, because it is tied to our latest version of the POSPac engine.
Yeah, and that means it's going to be, to my understanding, it's the latest is supported, at least I know 3.04. That is definitely supported.
Okay, 3.04. Okay, we can also confirm that as well. The next question is from Andrew. Is it possible to submit photo ID files for multiple cameras? In the web app, we showed one camera, one photo ID. So I guess the short answer is we don't have that ability yet through the web app, but that's definitely a great suggestion.
Oh, yes, good idea.
Yeah. Then Andrew's got another question, which is there an API to submit to the web app programmatically? You want to handle that one, Nico?
I think it sits better with you.
Yeah, I mean, we do have an API that's available to integrators, and there's a process of becoming an integrator and signing an OEM agreement. So we do have an API. It's not publicly available. That's something that we can make available to certain integrators.
Right, that's correct. So for the ApplanixPPK, that's not possible. That's a web app. But for interested, integrators, there's an API, as he says, and that requires a specific agreement, and those things are definitely possible.
Yeah. Okay, and then we have Harsel's question about how long do we store the data and how secure is the data in the cloud? I mean, we haven't finalized the length of data right now. We're actually in the process of finalizing that. So it's probably, can't remember what we talked about, it's probably in the 30 to 60-day range.
Right.
So that's still yet to be finalized. And the question about security, I mean, everything's stored within the big Trimble cloud infrastructure, and Trimble cloud follows all types of security protocols, and we're always up to date with the strictest protocols. I mean, I don't have a specific answer on security, but it is, of course, the top priority at Trimble, and everything is hosted on our own infrastructure.
Yeah, that's right. So that's my perception as well. Top priority is definitely security. That's always being worked on.
Yes, yeah, it's an ongoing thing within Trimble. And the next question is from Andrew. I think you kind of answered that when you showed the results file, but the question is, do the log files contain what's needed to graph, like to graph the viewer that's usually included in POSPac? So I think the answer is no. A lot of the log files are the ASCII log files, so they're more intended for, I guess, like a human to interpret the logs and look into them for more specifics. But there are some, like the SPET files obviously is there, and there's a few other binary files that can be mapped. But in terms of log files, I think most of them are in ASCII format.
Yes, the log files are, that's correct. Many of those log files are really in ASCII format. So for instance, you have one that gives you an overview of the single processes that run there. And it will say success, not success, depending on. And there's others that are all ASCII files that give you information based on the time tag, which is CPS seconds. So in case of something that's going wrong or went wrong, the log files will give you a good insight.
Okay. And then Michael's got one more question: is UTM the only supported coordinate system?
I can take that. Yes, at the moment, that's the only supported coordinate system. The reason is we wanted to keep it simple, and we didn't want to confuse with too many, mapping frames at this time. And most of other photogrammetric software is capable to do transformations into other local systems from the UTM. So that said, again, we wanted to keep it simple. UTM is the only one right now. But yeah, if there's a need, we always can extend going forward. We're always learning from you guys, and we are very open to change and to adapt this web app to your needs. So going forward, just let us know what you think is good. We'll consider it. And your feedback is always very, very welcome.
Yeah, that's a great point. There's actually like a little bubble on the bottom right inside the app. That's a great place to ask questions and also to send your feedback as well while you're using the app. Another question is from Igor. It says, what rover systems would you recommend for use with drones like Phantom 4 Pro V2 and the Metris 300?
Actually, as I said, it's very open. As long as you have a Rhinox file that you can download from your drone. The Rhinox file contains the raw observations in at least a frequency of 1 Hertz. As long as you have that, whatever the receiver is, whatever the platform is, you can run it through the ApplanixPPK app and process your data. Yes, of course, DJI Phantom 4 RTK is supported, a bunch of others. But as I say, as long as you get the Rhinox file from your platform, you can throw it into the ApplanixPPK app. You can get your data processed.
Okay, perfect. And Robert has a question. Actually, he's got a two-part question. First question is, if my base station has local coordinates, can the output be not local datum?
Not sure what that means. I think that's something we should be taking offline. Your base station have local coordinates and we would process something in the system, but I'm not sure exactly what local coordinates means. So I would need to have a better explanation.
Okay, and the second, maybe we can follow up. Yeah, maybe post-webinar, I can follow up with more details. And the second part is, if my drone has no RTK capability, can I still use this processing? But I did, I guess I'm saying I did have base station observations. So if there's no RTK,
can you repeat, please, Henny? Can you repeat?
If my drone has no RTK capability, can I still use this for processing?
Yes, you can, as long as you have access to a Rhinox raw file. I know from some platforms that don't have RTK, at least I know it from one specific, the customer has no access to the Rhinox file. And in that case, of course, it doesn't work. So again, the mandatory part here is to get a Rhinox file from UAV, from that platform. So the dynamic Rhinox file. And then whether you had RTK on it or not, does not matter. We're just taking the raw observation from your UAV, GPS or GNSS, whatever the satellite navigation was that was tracked, and we can process it.
Okay. Next question is from Alexander. Is it possible to get a result at a smaller interval than 1 hertz? So for example, if the goal is to geotag each frame of an infrared video at 30 hertz or 15 hertz, is that possible?
I think there's a limitation right now. I don't know exactly what it is. First of all, if you process your solution and you want to have a higher interval, it means that the raw data of your Rhinox file need to provide that interval. So let's say 20 hertz. If you want to have 20 hertz, your Rhinox file from your UAV needs to be 20 hertz, and your base station data as well. If your base station is only 1 hertz, then we cannot spit out the 20 hertz, right? So this is depending on the frequency or data interval of the rover data and the base data. And then there's another dependency that relates to our engine. So how much can we really process? I believe we can go up to 20 hertz, but not 100% sure. So that's really something we would need to take offline as well and discuss.
Okay. And Xavier's got a question about pricing. Any hint about the pricing of the different subscriptions? I think we did cover that a little bit. Maybe you want to slide back to quickly review that, Nico, if you have. Yeah.
Yeah, I'm just going back, but we have those different models, but at this point, we're not discussing any pricing.
I see.
We are still working on the price model. So we're still trying to find a decent price for the market. So that's why I didn't mention it.
Okay. And Matt's asking, is there a way or will there be a way in the future to load rover T04 files into the app? Now, our missions collect T04 files for every minute of flight.
Right now, this is not supported, but we can take that into account. Depends on, the application. We would need to understand why a T04 file is loaded, what the application is. And then we can definitely take this one into account. But another thing, so that's another topic that probably it's good to take offline in the discussion. So please use the chat, this little icon there in the app, or you can also address questions directly to me in an email, and then we can follow up on that one.
Okay, perfect. And Adita's asking, what base stations can be used? Is the Reach RS Plus base station supported?
Yes, everything is supported as long as you provide Linux files. That's what I'm saying. So there's many base stations out there, many manufacturers of base station, and they all have their own native format of the base station data, right? We're not supporting all of these different formats. That means you would need to convert it into a Linux generic format, and then you can load it into the app. Except of Trimble receivers, obviously this is directly supported. But anything else would need to be converted into a generic Linux file format, and that's either Linux version 2 or Linux version 3, and that is supported.
Okay, perfect. Another question is, a mission has been taken months ago without RTK. Can we still get the PP-RTX correction?
Yes, it goes back many years, actually. I don't recall exactly, but I think 2014 or something like that, or even earlier. So yes, you can process data that are 1, 2, 3, 4 years old, no problem.
Perfect. And then Matt's asking, I think we kind of covered this already. It's about, do you plan to expand and accept more file types beyond the Linux? Like our POSPac UAV accepts T04, for example. I think we covered that already in the previous question. That's something we may consider depending on the use case, but currently this is designed for Linux only data.
Yeah.
And I think we got a few more. One question is, what is a recommended GPS update speed for high-speed UAVs? I guess it means what's the frequency of GPS?
I think we're still good with 1 Hertz. So 1 Hertz data is also what's being used, for instance, in the manned airborne industry. And as you know, typically manned airborne platforms can fly much faster than UAVs, at least to my knowledge. And we're using 1 Hertz data there still to get a decent XT orientation for all the sensors or direct georeferencing information. So 1 Hertz is sufficient.
Okay, perfect. In terms of questions, I think we've covered them all.
Great. Then I think we can glue it up. We are going through this Q&A session. So I would say thank you very much, everyone, for your attention. It's been a great session, I hope, for you guys. For us, it was definitely. So if there's any follow-up questions, we are available. Of course, through the web app or email address. You can also fire your questions to the email address tech support at applanix.com. And we will definitely answer very quickly. Okay, thank you very much then for your time. Have a great day and keep in touch. And please go to the web app and use it.